Testing, testing. All right, hello. This is Java, and I'm working with Chapter 6, and we're going to be looking at our shared program code. The shared program code, and the shared code for this chapter is exercise 6.17 on page 239. Write a method is even that uses the remainder operator, which is our percent symbol, to determine whether an integer is even or odd. The method should take an integer argument and return true if the integer is even and false otherwise. Incorporate this method into an application. That means we're going to be writing our public stat main, and this program will execute at the main method that inputs a sequence of integers one at a time and determines whether each is even or odd. So with those directions, start looking at some code. We're exercise 6.17. Our solution is our even odd.java, where it must begin with an uppercase for a file name. We're asking for input from the keyboard, so we'll import java.util.scanner. And we'll be naming our class even odd, as is the same as the file name, even odd.java. So we have our public class even odd and our end class documented. We're supposed to determine whether the integers that we input at the keyboard are even or odd. So we're going to start with public static void main. And there's our begin main, and here's our documented end. I guess it's not documented. End class main. It's right here. End main. Let's see, we have scanner input is equal to a new scanner from system.in. Input is our variable name that captures the input from the keyboard. System.out.print formatted. We have a string and a new line, fit a string, and then a new line and another new line quoted. And we're going to place the first string, enter numbers to determine if they are even or odd, and then a new line, and then place our second string, type -1 to terminate input, and a new line, and then another new line for our output status at this point. So we've prompted the user to type even or odd integers at the keyboard. We'll determine then if they are even or odd, and type a -1 to stop. We're declaring number to be an integer, and we're going to get the next input integer from the keyboard and assign it to number. While, here's our while begin and our end while. And within the body of the while, condition of the while is while number is not equal to -1. The user types an integer other than -1 will process the body of the while. If is even number. This is a method call. If is even. Notice that it begins with a lowercase, no spaces, and it has a parameter list, and we're going to send the current value of number to the is even function. So we're going to look for and find the is even method and it is a public, going to be called from static void main. It's going to return a Boolean data type. Is even is the name, there's no space. We follow immediately with the open paren, and it's expecting that an integer is going to be sent to it when it's called, and the current value sent to it is going to be assigned to number. Number is a local variable now known to the isEven method. We are calling if isEven, we're sending the current value of number. It's going to be assigned as an integer to number within the isEven method. We're going to return a Boolean value. Remember, that's true or false. We're going to return the expression number %2. Now, remember that our percent symbol, is our remainder operator. The percent symbol is our remainder operator. Page 51. So here we're going to calculate. Now, let's say that number, the user input 5. So we have 5% 2 equals 0. So we're asking the question, is number %2 equal to 0? We're going to return either a 0 for false or a 1 for true. Now, 5% 2, we're just going to go over here into our scratch pad, and that's 2 goes into 5. 5 divided by 2, well, that's, let's see, 2 times 2 is 4, subtract, we get 1, with a remainder of 1, and we're going to return the integer remainder. The percent symbol calls for the integer remainder. So now from this expression, our answer is 1. And is 1 equal to 0? No. So the whole expression returns false. And 1 is not equal to 0, so we return false to the calling environment. And the calling environment is if isEven number is true. Well, in our case, it's not, it's false. So we'll process the else portion. Else system.printf %d is our number. I used 5 in my example, is odd. New line, and we fit the current value of number into the percent integer position. So 5 is odd with a new line and a new line. Then we're going to reassign our condition of the while variable. Number is equal to input next int, and we should probably prompt the user again just to remind them the purpose and how they can exit. So you might want to do a better job of prompting the user with user directions again. So a reminder, enter an integer, a positive integer, but type -1 to terminate your program. So let's type in another number, and let's assign 4 this time to number. We're going to return to the top of the while. Number is not equal to -1, so we're going to, if isEven, and we're going to pass 4 to the isEven method. So we're going to find the isEven method. Public static Boolean isEven is the name of the method, and immediately follow with a parentheses. And the parameter list, we're expecting an integer to be passed to and assigned to number. We're passing our value from the calling environment, which is 4. So number is going to be assigned 4. We're going to return, and this time we're going to calculate the current value of number %2 equals 0. And my number this time is 4. Now the mod operator says 4 divided by 2. So 2 goes into 4 2 times. 2 times 2 is 4. And we want to capture that remainder, which is 0. The remainder is 0. Actually, any even number divided by 2 would have a remainder of 0. So number divided by 2, capture the remainder, is equal to 0. So the remainder is 0. 0 is equal to 0, so that returns true. So back at the calling environment, we're returning true for our Boolean value. If is even number is true, we system.out.print formatted our current number as an integer, which is 4, is even with a new line and a new line. Again, we prompt the user and continue to enter positive integers until the user types -1. To exit the while, we exit the while and we exit main. Notice that our method or methods follow the main end statement, and our isEven method actually contains only the one statement: return the value of our expression number %2 equal 0. Since we're asking for a Boolean value to be returned, either 0 or 1, we have to make sure that we're testing something with a relational operator that would return actually a 0 or a 1, indicating true or false. So let's take a look at NetBeans. This is our evenodd.java file. Import java.util.scanner, public class evenodd, and sure enough, it ends right here with my methods following. And right here, I guess my methods are before the end of the class, but within main. Public class, we'll just click there. The class ends, and then within public static void main, there's your end main, and your methods reside after your end main, before your end class. So they're within the class, but after main method. Scanner input.new scanner input. Okay, we're using input scanner. Prompt the user, enter integer positive numbers to determine if they're even or odd. Type a -1 to terminate your program. Input number is assigned an integer with our input.nextInt. And that's actually priming our while statement, because our while number is our condition variable. So number has to have a value previously assigned to it, and we just assigned it from the keyboard. So while number is not equal to a -1, we're going to continue to process the while. Here's the body of the while. Within the while, we're going to call the if statement. If is even starts with a lowercase and an immediate open paren. It indicates that it's a method. Starts with a lowercase letter for its name, no spaces, immediately followed with the open parenthesis. So this is a method call. if is even number. So I'm going to call is even. I'm going to pass or send the current value of number. We're going to find the is even method. Is even. It's public. It's going to be called from our static void main. It's going to return a Boolean type, and it's expecting to receive an integer, and it's going to call it locally by the name number. So we're passing the current value typed by the user, we're assigning it number within the is even function, and we're going to return a Boolean result of number %2 equal 0. Using the remainder operator, we're going to do integer division by 2 of the number typed in by the user. Any even number divided by 2 has a remainder of 0, so we would know that if this is true, then we've typed in an even number, and any odd number divided by 2 results with a remainder of 1, and 1 is not equal to 0, so we'd be returning a Boolean value of false. So if your number is an even number, then is even returns a true result, and we process system.out.print formatted. Your number is even. If is even determines with the remainder operator Boolean test to be false, then we'd process the else portion of the if statement, and your number is odd. We're still working within the while loop, so we do need to reassign the condition of the while. Number is reassigned, and we talked about having maybe some better user input to better prompt our user how to continue with positive integer numbers to test whether they're true, even or odd, and how to terminate your program. But we're going to reassign typing a value in for number from the keyboard until we type -1. -1 causes the condition of the while to test. False, number is equal to -1, which is not equal to -1. -1 is equal to -1, so that tests false. We exit the body of the while, and we just ignore or pass over the methods. They're just statements that allow us to process the method when the method name is called, and we end the class. So let's see what happens when we run. Type numbers to determine if they are even or odd. Type -1 to terminate. So I'm going to type 2. Okay, so I input 2 for my number. While number is not equal to -1, it is not, so that's true for my while condition, so I'll process the body of the while. If is even, I'm calling the is even method. Methods begin with a lowercase letter and follow immediately with the open paren. I'm going to send the current value that I entered is 2 to the method. So calling the method and sending an integer value, number is going to be assigned 2, which was passed to number. I'm going to process the body of the is even method, returning the result of the expression number mod 2 equals 0. Well, 2 mod 2, 2 goes into 2 evenly with a remainder of 0. So number mod 2 returns 0, and 0 is equal to 0, so that's true. So we return true to the calling statement if is even number. If true, we process the true portion, system.printf. We're going to print an integer value. My number was 2. 2 is even, and a couple of new lines. So we input 2. 2 is even is my output. There's a couple of output lines, and I'm going to type my next number, where again we said maybe we do need to prompt our user that it's now time to type your next integer, positive integer, for testing purposes, or -1 to quit. But let's just go ahead and type a odd number. I typed odd is even is called. If is even with 3 as a number, I'm going to process the is even method, sending the current number value 3 to it. Public static Boolean is even is expecting an integer to be passed to its variable number. Number is passed the value 3. We're going to return from this expression either a Boolean true or false. Now remember that 3 divided by 2 is 1 with a remainder of 1. We're capturing the remainder with the remainder operator. So 3 mod 2 is 1. Remainder 1. 1 is not equal to 0, so that returns false. So we're going to return a Boolean value of false to the calling function. If is even number, this returns false. If false, I'm going to process the else portion, system.out.print formatted my number position for an integer value to be printed. Number is equal to 3. 3 is odd. And a couple of new lines. Be sure to prompt your user better than I did. Skipped a few. I guess I'm facilitating the code, not writing the best code. We need to prompt the user again. And we are reassigning our while within the while. Before the end of the while, we are attending to reassigning the condition of the while. Now, if I type -1 as input at the keyboard, we go to the top of the while number is not equal to -1. It is false because -1 is equal to -1. So that's false. We exit the while. And we skip the method or methods, and then we're ending the class. So we are still running this program. Let's type in 15. 15 is odd. 27 is odd. 34 should be even. And then let's type -1 as our sentinel terminal value, and your program halts. Now I would suggest that you have already viewed and read the chapter and viewed the video companion videos, so that you are walking through the code for the chapter, for all the sample programs within this chapter. And I'd just like to kind of bring you up to speed a little bit. On page 203, we begin to introduce some of our class methods, and I'm going to talk about the math class. Now our math class is part of java.lang package. So our math class is imported implicitly, so we can use math class at any time within our code. Class math is part of the java.lang package, which is implicitly imported by the compiler, so it's not necessary to import math class in your program. And then on page 204, we are looking at the math class and the methods within the math class that we can call. So the absolute value, the maximum, the minimum, power, square root. Those are some that we're interested in looking at. So we may have math dot square root of a number. That's a double. So it returns or evaluates to the square root of 900 as a double would evaluate 30.0. Thirty times 30 is 900. Math dot absolute value of 23.7. Remember that absolute value returns the absolute distance from zero. The absolute distance from zero, so 23.7 evaluates to 23.7 units from zero. Math dot absolute value of a negative 23.7. Remember that absolute value returns the absolute distance from zero. Negative 23.7 is absolutely 23.7 units from zero. We don't talk about negative distance, just talking about the absolute distance, absolute units, irregardless of sign. And the math dot absolute value of 0 is 0 units from 0. Math dot max. We're looking for the maximum of two numbers, 2.3 and 12.7. The maximum of these two numbers is, it will evaluate and return 12.7 as the maximum of those two numbers. The math class dot max of negative 2.3 and negative 12.7. Careful on your number line now. We're looking at two negative numbers, and negative 2.3 is greater than a negative 12.7. So the maximum of those two numbers is evaluated and returned. Math.min of two numbers, negative 2.3 and a negative 12.7. Remember the number line now. The minimum value, negative 2.3 or negative 12.7. Negative 12.7 is less than negative 2.3. Math.power. Math.pow. Looking at the power function. Its template is a base raised to an exponent. So math.power, if my base is 2 and my exponent is 7, it evaluates or processes to, I'm just going to go over here to scratch paper. My base is 2, my exponent is 7, and 2 to the 7th, 2 raised to the 7th power is 128. So it returns 128.0. Remember, it's returning a double. Math dot pow. My base is 9.0. I guess this would be 0.0 and 0.0 here. They're doubles. 9.0 to 0.5. Scratch paper again. My base is 9.0 raised to the 0.5. 9 raised to the 0.5 is 3. 3.0 as a double, so it'll return 3.0. This is actually, maybe from your math, remember that'd be the same as 9.5 is to the 1/2. And 9 to the 1/2, that's asking for the square root of 9, and the square root of 9 is 3. 3 times 3 is 9. A little bit of review there for your math. Base raised to a power, to a base to a fractional power. And then math dot square root, 25.0. The square root of 25.0, the square root of 25.0, it's going to return 5 as a double. 5 times 5 is 25. So on page 204, these are probably the most likely math class methods that we're going to run into first. But you can always come back to this page 204 to look at others by definition as they're defined on that page. Also, the math class declares two constants, math.pi and that's uppercase for our familiar high precision value representing the ratio of a circle's circumference to its diameter, 3.1415, and of course it's a higher precision than that that's returned by math.pi. And that's on page 204 as well. Okay, there's another example of a method call with your figure 6.3 maximum finder on page 205 and 206 in your textbook. And this is an example of a system call to the method maximum, which expects to be sent or receive 3 doubles that are local to the maximum method, and then processing takes place and the method returns a single double value to the calling environment. So you may want to visit or revisit figure 6.3 maximum finder.java file and experiment again with NetBeans and create a project to test the calling of the method maximum, expecting 3 double parameters that will be returning a single maximum value to the calling environment. All right, I'll follow up with another lecture for chapter 6. Thank you very much.